What's going on, you guys? So today we're going to do intersection of two linked lists. So we're going to write a program to find the node at which the intersection of two singly linked lists begins. For example, the following two linked lists begin to intersect at C1, right here. Okay, so we could have two lists that are different lengths, as we see here. They could be the same length. One could be null, the other could be null, or they could both be null. So let's think about, so if either of them are null, we're just going to return null. So if head A is null, or head B is null, we're just going to return null. Okay, and then what are we going to do if there's different lengths, and what are we going to do if there's same lengths? So let's do a couple examples. Try and get a feel for this. Okay, so, okay. All right, let's use two pointers. So this is going to be pointer A, and this will be pointer B. So let's say we start at the beginning and we travel over these. Yeah, I think this example might be wrong. It's saying the intersect value is 8. I'm seeing the intersect value is 1. Yeah, so let's just assume that this example is wrong. So, okay, so on each, let's move A and B to their next values until they're equivalent. So this is an example of let's just make this let's call this same lengths. 1 is null, and then let's also consider different lengths. Okay. So we'll just add a fake example. We'll just say this is I don't know, 9. Okay. So they're going to be the same length, and we got to figure out where are they? Where's the intersection point? So let's move them forward until we get to an intersection point. So let's move A. Let's move B. Okay. So A does not equal B, so we'll move A forward. And A equals B, so we'll just return A in this case. Okay, so that's kind of simple. And now what about different lengths? So this is going to be interesting. So does A equal B? No. Let's move forward. A equal B? No. Move forward. A equal B? No. Move them forward. Equivalent? No. Equivalent? No. So move B here, and then where are we going to move A? This is the question. Yeah, so where do we move A once it reaches the end? Oh, and yeah. Okay. Same length, intersection exists. What about, so we have to deal with intersection does not exist as well. Intersection exists. We'll come back to that later. Okay, so let's say we move A back to the beginning of A. Did I do that right? So 1, 2, 3, 4. 1, 2, 3, 4. Okay, yeah. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Are they equivalent? No. Alright, so let's move B back. And let's move A forward. Okay, are they equivalent? No. Equivalent? No. Equivalent? No. Equivalent? No. Okay, what about if we move them, like once we get to the end of A, we move it to the beginning of B. So let's see how we're going to do that. So let's see. So move A, 1, 2, 3, 4. Let's move B 4, 1, 2, 3, 4. And then we move A, let's say, to here. Okay. Wait. Man, okay. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And now let's move A and then B. Okay. Let's move them both. Oh, did this wrong. So we want to move B to the beginning of A. Okay, so where is B going to be when A is at the beginning of A? So he's moved 1, 2, 1, 2, 3, 4, 5 spots. So B will be 1, 2, 3, 4, 5. So B is here when A is at the beginning of B. So B will move to the beginning of A, and A will move to 6. B, A, okay. Equivalent? No. Equivalent? Yes. So we're going to return 1 in this case. Okay. So what about when there's no intersection? Let's do that. So we need to add these nulls. So on the end of a linked list, the last value is always null. Okay. Okay. Let's think about this. So the same thing is going to happen. So they're going to become equivalent when they're both equal to null. So we saw that they're able to become equivalent if when we reach the end of one, we go to the beginning of the next one. So in this case, we'll return a real value. In this case, we'll just return null. So it's the same situation as if a intersection does exist. Okay. So what's our code going to look like? So we'll use this, and while A does not equal B, what are we going to do? We'll set A equal to A dot next if it's not at the end. So if and how do we know if it's at the end? If A is null, we'll set A equal to head B. Else, okay, and search for A, replace with B. so if b is null, we'll set it equal to head of a. Otherwise, we'll do b dot next, and then we'll return just return a or b, either one. Return a. Okay. Let's see if this works. Okay. Add these brackets, and let's see. Oh, right. Variable a equals head a. B equals head b. So there you go, guys. And what's the runtime for this one? Let's think about this. So if they're different lengths, then you're gonna have to, if they're different lengths, you will need to go O of n plus n plus m, where n is the length of head A and m is the length of head B. If they're equivalent, you just have to go O of n. You'll only need to traverse it once. Yeah, so O of n plus m time complexity and O of 1 space, because we're just using the 2 pointers. Okay, yeah, so I had a little trouble with this one at the start, but just walking through the examples, you know, moving A and B through the values, that helped me a lot, and also the discussion section. Yeah. Anyways, so this has been an intersection of 2 linked lists. Stay tuned for the next one. See ya.